honestly, even after someday when COVID is gone, I'll probably still do it just because I think it's pretty nice for the students that, are sick and miss class just for regular stuff. Then it's just a little easier. You can just go back and watch the video. It's kind of like you didn't really miss class at all. Okay. So if we look at this first box, it says, in the case of repeated multiplication with the same number, we can rewrite the expression using exponents. For example, 4 times 4 times 4. So I would like for you to, real quick, write that out using an exponent. Okay? So what is 4 times 4 times 4 if you use an exponent? That is right. Okay, so it'll look like, oh dear, jumped on me. So it'll look like 4 with what we'll call a superscript. Okay, so we'll get used to superscripts and subscripts. Subscripts would go where? At the bottom. Yeah. Okay, and subscripts are more of a like you're naming a particular term. Okay, it's like a label. A superscript, okay, which we'll put up at the top, is an exponent. Okay, so it's a power or a degree that we're using to adjust that first number with. Okay, so parts of an exponential expression. Okay, you have the base. Okay, you have the base right here, which is your kind of main integer. Okay, the number that we're going to be adjusting. Okay, and what do we call the little n? So there's a lot of different names for it. Okay, so we can call it an exponent. We can call it a degree. We can call it a power. Okay, all of those different variations are going to be the same thing. Okay, so you would read this as x to the, now we're just using n to say any number, so it'll be to the nth power. Okay, x to the nth power. So if I replace the x with a 2 and I replaced the n with a 3, how would you read it? How would you read this right here? 2 to the third power, right? Okay. So, I don't know. Should I be nice and let y'all use calculators?
Yes.
Yes.
I don't know.
And I have Jack and Jordan. Will y'all hop up and grab the calculators? Pass them out to everybody, please. Okay. So let's go ahead and write these out. Okay, we've got expanded notation. Okay, so this is, instead of us seeing it as the exponent, this is it written out. Okay, so 11 times 11. How would you write that as an exponential expression? Yeah, 11 to the second power. Now, when you have stuff, and we'll get into it a little bit here, you'll get into it a lot in Algebra 1 and even more in Algebra 2. To the second power, we could also call that what? Do we know? It's not something I would expect you to know. I'm just seeing if anybody does. Squared. Okay, so we'd call it 11 squared. Okay, and all that means is that you are multiplying 11 by itself twice. Okay, so what is the value of 11 times 11? Now, these are the things that you will start to need to be able to memorize, just like you do your multiplication facts. Like if I say 4 times 8 when you were in elementary school and you started learning multiplication, you do those multiplication tables and you do the, maybe the like minute practice where you try and do as many problems as possible, and you start to kind of ingrain those, okay, into your brain. The squared stuff is stuff that'll be really useful if you can start to know what it is. Okay, anybody know what 11 times 11 is? 121. And it keeps jumping on me. 121. Okay. 2 to the how many power? 2 to the 7th. Okay. So I know 2 to the 6th is going to be 64. So what's 64 times 2? 128. Okay. Now, on your, I'll borrow this calculator just a second. I'm seeing if these calculators have them or if it's just the bigger ones. These calculators do have them. Okay. Do you want to see how you can put in 2 to the 7th in the calculator?
Yes.
Without having to do 2 times 2 times 2 times 2 times 2?
Yes.
Okay. So let me pull this up real quick. So mine looks a little bit different than yours because mine is a graphing calculator, okay, not a scientific calculator, but you've got the same button, so we'll make it work. Okay. So if you would look at your calculator, okay, you are looking for the caret. What does the caret look like? Anybody ever heard of it? I can't zoom in, so. Okay, the caret is going to be, okay, can you see my little marker? It's kind of hard to see. Here's what I'll do. I'll start up here at the D-pad, the little directional pad with the arrows. Okay, you see my marker? Okay, I'm going to go down below the clear to this little button right here that has the like arrow pointing up. You've got that button on your calculator as well. Okay, so what you're going to do to punch in 2 to the 7th, you're going to hit 2, and then you're going to do this little caret, okay, which on yours is probably just going to show the caret. I don't know if it'll actually give you a little blank for the exponent, okay? And then I just type in 7, hit enter, it'll give you 128. Did anybody not find it? Okay? If you haven't and you want to know and you don't want to ask me right now, just let me know later, okay? And I'll show you. So that'll help you out. So let's go back to, okay, what about -5 times -5 times -5 times -5? Okay, now how do we need to write that? So if you write it like this, okay, technically what you're writing is 5 to the 4th, and then you're going to multiply it by a negative at the end, okay? But we're wanting to multiply -5 by itself, right? So you need to be able to write it with parentheses, okay? You need to show, you're showing that the exponent is including that negative sign with the number, okay? If you don't write it like that, or especially when you're typing into the calculator, if you don't use the parentheses, the calculator is going to read it like you're doing negative times 5 to the 4th, okay? 5 to the 4th is going to be what? Anybody punch it in yet?
It's
625. And then it's going to be multiplied by a negative, so you'll get a -625. That's not the right answer, right? Because it's going to be a positive, okay? So parentheses are very important, okay? So it should be 625. Okay, 1/4 times 1/4 times 1/4. Parentheses are very important here as well. Okay, let me show you why. You want to write it 1/4, not squared, cubed, or to the 3rd. Okay, if you don't use parentheses, the way that you're going to punch it in the calculator is 1 divided by 4 cubed. What's it going to do? Because the calculator goes order of operation. So what's it going to do? It's going to cube the 4 and then go 1 divided by whatever 4 cubed is, which is 64. Okay? You don't want that. Now, it might come out to the same answer, okay, this time around, but you got to be careful with it, okay? So make sure that you use the parentheses. Okay, so what did this come out to? 1/64. Okay? I'll do number 5 with you, and then I'd like for you to try some on your own. So let's do number 5. Okay, we've got 7 times 7, so that's going to be what?
7 squared.
7 squared, or 7 to the second. Okay, times how many powers of 4? 3. So we're going to go 4 to the third. Or cubed. Okay, and so you're going to do 7 squared, which is, you should be able to do this one. 49. There you go. And then we just did 4 cubed, or 4 to the third. You're allowed to answer. What's 4 to the third? We just did it on the last one, guys.
64.
Thank you. Okay, 49 times 64 is what?
3,136.
Yes. Okay, please do 6, 7, and 8 on your own. Okay, as you're ready, you can start looking up and checking yourself. Apologize that my A's and my 9s look the exact same, but there's nothing I can do about it. I am no artist. So what's going on then with that is that right there. Did you use that? Use that. Okay. It doesn't like the, for some reason, when you're using exponents, it's not going to like the subtraction sign as the negative. Okay. Okay, here's 6, 7, 8. For 6, hopefully you ended up getting. You have a question, Patterson?
No.
Okay. You got 8 to the 4th times negative 2 to the 3rd. Should have given you negative 32,768. Number 7, you got 2/3 squared times 9 squared. Okay, which ends up giving you 36. Then on 8, it's our first one where we have a what? Variable. Okay, a variable. So we have a. We're saying a to the 9th. Because we don't know what a is, can we solve that? No. Okay, so we can't give a value because we don't know what a is. Okay, so let's look at a couple of more of those that have the variables involved. Okay, so we've got number 9. We've got xy times itself. How many times? 5. So what do we think is important right here since we're working with two different variables that are obviously being multiplied together. How are we going to write this as like an exponential form? What's important to put in? Parentheses. Okay? Because again, if you write it x, y to the fifth, you're only doing what? Yeah, you're only doing y to the fifth. Okay? If you want to do xy to the fifth, you've got to add in those parentheses so that it includes it. Okay? Anything to put over here in the value? No. Okay? So let's look at 10. Stay with me. Okay? These notes are not very long. Stay with me. Number 10, we've got R, S, and T being multiplied together. Okay? So how many R's do we have? Okay, we have R squared times S. We can go with, okay? S to the what? Fifth times T to the third. Okay? And again, same thing. Okay? We'll just leave that value spot blank. Okay, so this one now we're going to start mixing, okay, our integers with our variables, right? So how many 9s do we have? 3 times, we're using K. How many K's do we have? 6. Okay. Now, are you going to have something in the value section over here? Yeah, you can this time, okay? Even though we don't necessarily know the value of K, we can figure out the value of 9 to the third. Okay, what is the value of 9 to the third? Good. 729. Now, how do I write the rest of this? Perfect. It's still being multiplied by K to the 6th power, right? We just don't know what that is. Okay? So you'll go ahead and just put it back on, okay? After you do the multiplication that you can do, okay? So let's look at actually, you do number 12 on your own real quick. Okay? How many negative 7s do we have? To the 2nd power times m cubed times n squared. Okay? So we can put something in the value column. What's negative 7 squared? 49 m to the third n squared. What's up? So we had negative 7 2 times over here. So we did negative 7 squared. So that's negative 7 times negative 7. Okay? Okay. Number 13. P minus 2. Okay, this is something you will get very used to working with in algebra and algebra 2. Okay, we would call this it starts with an F, P minus 2 in parentheses. We would call it a factor. Okay, P minus 2 times P minus 2 times P minus 2. How are we going to write that? P minus 2 cubed. And when you get into algebra 2, you'll end up having to express that all the way out. So you'll actually multiply p minus 2 times itself 3 times and be able to show what that polynomial looks like. Eventually, we will get there. No value for that one. Okay, last one on this page. Let's look at 14. We've got a plus b times 6 times 6 times a plus b times 6. So how many 6s we got? Okay, so 6 to the third times a plus b, how many times? Twice. Okay, so we can put something in the value. So 6 cubed is going to be 216 times, not x, times a plus b squared. Okay, so let's look at next page. Just a few other rules to talk about, and then you'll have plenty of time to finish your homework before you leave class today. Zero exponent. Okay, so this is a rule that you will just have to remember. Okay, anytime you have a 0 as an exponent, okay, so your base number is being raised to the 0 power. What's that? It does not. You would think it does. Okay, it is going to be defined as 1. So 1 to the 0 power is 1. 2 to the 0 power, 1. 1, 1, 1. Yes, always and forever. Okay, we also have a negative exponent rule. The negative exponent rule, okay, takes your base and your exponent and turns it into its reciprocal, okay? So what that means is we're going to flip it. So this is x to the negative n. So that is the same as doing 1 over x to the positive n. Okay, so you're just going to flip it. And then you can work out whatever problem that is with now a positive exponent. Okay. What's that? We will do one. So let's look at number 15. You have x to the negative 2 power. This is going to be written the same. So 1 over 5 to the second power. Okay. Now what's 5 to the second power? 25. So your answer is just 1 over 25. Yeah. I would like for you to do 16. Let's do 16, 18, 20. So just those evens. And I'll just go ahead and start putting them up here. You can check as soon as you're ready.
Wait, 16, 18, 20?
Mm-hmm. Okay, so as you're ready, you can check yourself. See how you did. Okay, what do we think are some common mistakes? Not flipping it. Okay. Mm-hmm.
I forgot to put the 1 over the actual answer.
Okay. Yeah. Mm-hmm. I've also seen that when you flip it, okay, I've seen students still leave that negative in there, and then they make their answer negative. Okay, just be careful that you don't do that as well. Okay. Okay, so let's look at just a few more so that we are fully covered. If you have any questions so far, just make a note of it, okay? And you can ask me a little bit whenever everybody kind of gets going on their stuff. So let's do we want number 21 or 22? We can do 21, okay? So first, we're going to rewrite it, okay, by taking the reciprocal. So we're going to do 4 to the negative 3 will be 1 over 4 to the third times 1 over 7 to the first power. Okay. What is 1 over 4 to the third? 1 over 64. Okay, times 1 over 7, which should give you 1 over what?
Uh,
448. Okay, try and do 23 and 24 on your own. '23 and 24. If you're not at least trying to do these, you're wrong. Okay, I'll go ahead and start putting 23 up there. Here, I skipped a step. Let me put something else in there. Okay, kind of ran out of room on 23. I'll talk about it in a second. I'll go ahead and put 24 up there as well so that you can check yourself. Okay, here's 23 and 24. For 23, we got 3 to the fourth times 9 to the negative second power. 3 to the fourth came out to be 81. Okay, 1 over 9 to the second power came out to be 81 as well. So you've got 81 on top, 81 on bottom. That's going to come out to be what? Yeah, 1. Anything over itself is going to be 1. Okay, if you ended up getting 81 over 81 and that was your final answer, you'd get a 3 or you'd get a 3.5. Okay, it's still a good answer. The best answer is simplified. So 1. 24, you have 8 to the negative third times 10 to the second times 4 to the 0 power. Okay, so you have 1 over 8 to the third, which is 1 over 512, times 10 to the second power. What's 10 times 10? 100. And then 4 to the 0 power is 1. Okay, so you have 100 over 512. That is a good answer, but it's not the best answer, okay, because it can be simplified. You can simplify them both by 4. Okay, so you should get 25 over 128. Okay, last two that we're going to do are 27 and 28. I'm going to roll through them with you. Okay, try and do them on your own as I'm going. We've got number 27, which is r to the negative 6 times s to the 0 times t to the 11th power. Okay, so we're going to have 1 over r to the 6th times 1 times t to the 11th power. Okay, so that is going to come out to, what all are you going to have up on top? 1. What else? Nothing else? Not sure? T to the 11th is going to be on top as well. Okay, so you had 1 times t to the 11th over r to the 6th. Okay, where did I get the 1? From the s to the 0 power. Okay, then you're just multiplying across once you get all these done. Okay, so try and do 28 on your own if you haven't already. Okay, if you're getting lost, just follow your rules. Okay, we've talked about three different ones. Okay, if you're ready to check yourself, 28, we've got 1 over 3 to the 3rd times 1 over m to the 4th times n to the 5th. Once you multiply across, n to the 5th is the only thing up on top. Your 3 to the 3rd power comes out to be what? 27. and then you have times m to the fourth. Okay? Just take it piece by piece. Don't try and look at the whole problem and solve it right off the bat. Okay? Just follow your rules. You have the rest of class time to work on and finish your homework. Okay? Also, don't forget to do the summary at the end of your notes.